Hey everybody, welcome back. Today we are going to continue graphing the absolute value inequalities, but today the examples that we're going to be looking at is we're going to be graphing a system of the absolute value inequalities. So as you recall, a system is just graphing two or more inequalities on the same plane. And again, you can see that the notes are open on the left, and I have my Desmos graphing calculator open on the right. So let's go ahead and begin. So for our very first system, we have the first inequality is a linear inequality. We're going to graph a line. And the second one is going to be the absolute value function. So let's just begin here. Recall from yesterday's lesson, you want to type it in exactly as you see it. So we want y is less than or equal to, we want 1 divided by 2, and then we need to arrow to the right, and then we want our x, and then plus 4. If you don't arrow to the right, that x will be in the denominator and not the function that we need. So as you can see, this is a linear function right here, which has a solid line, and it is shaded below. So let's graph on entry line number 2, our second inequality. This time it's our absolute value inequality. So we want y is greater than, we're going to type the absolute value bars. We want x plus 4 inside. And remember to arrow to the right and put the minus 4 on the outside. Okay, let me move this around and we can zoom in, zoom out. So as you recall, when graphing a system of inequalities, you are looking for where the two graphs overlap. So the absolute value function or inequality right here was a dotted line and you shaded above. So this time it was inside the absolute value. And the line was shaded below. So as you can see, where the two colors overlap is in this region right here, this kind of triangular region. So it does ask us to list two solutions for this. So recall that a solution can fall within the shaded region or along the solid line within the shaded region, the overlapping, but it cannot fall on a solid and a dotted line. So this point, -8, 0, does not work. Remember, it has to be true for both of these inequalities. And if we substitute -8 in for x and 0 in for y on the absolute value function, it is not going to work. So you have a few options right in here to choose from to name any two solutions. So let's see, what else can we work with? So something like maybe a -2, +2. Let's go in here, we go. -2, +2. These are just examples. Remember, these are my examples. You can choose something different. How about maybe a +4, +6? Does that fall on that solid line right there? +4, +6? It sure does. So I'm going to go ahead and erase that and try that again. There we go. I'm going to go ahead and I'm going to pause and I'm going to graph this system in your notes for you. Okay, there it is graphed for you guys. And just remember that all we're looking at are where the two, for the solution set, where the two overlapping shaded regions meet. So that's what I went ahead and shaded in for you in the notes right here. Okay, so let's go ahead and let's try another example. Let's look at number 2. Another linear inequality as well as another absolute value inequality. So just to kind of continue practicing typing these in. So we're going to start off with the y on the first inequality is less than or equal to, okay, we want -2 divided by 3. Okay, so remember, because of the fraction, we're going to arrow to the right, put our x plus 5. Okay, so a solid line, we're shaded below. This does have a negative slope on the line. Okay, so let's go to entry line number 2 and let's type in that absolute value. Inequality, so we want y is less than. Oh, now we have a vertical stretch on this one, a 2 absolute value of x minus 1. As you can see, it just made our graph pretty skinny. We're going to arrow to the right and put a minus 2 on the outside. So just kind of reviewing those transformations, just remember that that 2 on the outside in the front is your vertical stretch. X minus 1 moved it to the right 1, and the minus 2 outside is the down 2. So there's your vertex. It did go right 1 and down 2. And that 2 in the front just made it really skinny. But as you can see, we have a blue graph and we have a green graph, and the overlapping is outside. So the absolute value inequality was a dotted line, and it is shading below. And the linear inequality was also shaded below. So you have countless solutions to choose from. Just keeping in mind that it cannot fall on a dotted line, and it cannot fall on the intersection of a solid and a dotted line. So these 2 points right here are out, okay? And the vertex is also out as well. We cannot choose any of those points, but we can choose something on the solid line. So any one of these decimals you could choose out here, or you can choose some decimals down here, or you can choose any points within this overlapping shaded region. So let's go ahead. You choose any points y'all want. Let's pick. I'm going to pick maybe -4, +3 sounds good. -4, +3. And I'm going to choose 5, -10. That sounds like another good one as well. 5, -10. All right, I'm going to go ahead and pause, and I'm going to get this graphed on the notes for you. There we go. Nice, pretty picture for you guys. Okay, so we're going to take a look at one example, and we're just going to look at a graph that was given to us and just see if we can identify some solutions or not. So let's take a look at our last example. And let me zoom in for you guys here. All right, so we were given 2 inequalities. One was the linear function, as you can see. Here's your linear function, which is a dotted line. And the second one was an absolute value. And this one actually had a reflection on it. So we're going to identify if the following points are part of the solution set or not. So just a yes or a no. So let me move this up, maybe zoom in a little bit more. So the overlapping for these 2 graphs would be this darkest region over here on the right, okay? So let's check the point 5 and -4. Let me grab maybe a red marker, 5 and 1, 2, 3, -4. And this one would be a yes. So I'm just going to use a Y for yes. Because this one does fall on a solid line, it does make both of those inequalities true. Okay, let's test the point -1, +3, -1, ooh, +3. Now, it is a solution for the absolute value, but not for both. So this one would be a no. Okay, let's test the point 2, -1. Oh, 2, -1 also falls on that solid line. So this one would be a yes, a solid line within the solution set. That one is a yes. Okay, let's test the second row here. 2, +2, +3 falls on a dotted line in the solution set, and that one is a no. And let's test the point 0, 1. 0, 1 falls on the intersection of both the solid and the dotted line. So it does work for the absolute value inequality, but not for the linear inequality. So this one is a no. And the point 6, +5, 3, 4, 5 is a yes. All right, so again, make sure that you're utilizing your Desmos graphing calculator and typing in the inequalities exactly as you see it. And just to remember that your solution set is where the overlapping region, the overlapping shaded region occurs. And make sure you are working on 2 days assignment.